Good morning, students. Today's topic in mathematics is the volumes of the solids. So the points and concepts to remember for you people are: number one point is the volume of a solid is the amount of space it occupies. It is measured in cubic units. For example, centimeter cube, meter cube. The next concept is the volume of liquid or fluid is measured in milliliters, liters or kiloliters. And here are some more concepts. 1 milliliter is equal to 1 centimeter cube. 1 liter is equal to 1000 milliliter. And because 1 milliliter is equal to 1 centimeter cube, so 1000 milliliter will be equal to 1000 centimeter cube, which is equal to 1 liter. And 1 kiloliter is equal to 1000 liter. And 1000 liter is equal to 1 meter cube. So you have to remember these values. A prism is a solid with uniform cross-sectional area. In the examples of the prisms below, the cross-section has been shaded. So these shaded parts are called the cross-sectional areas of the prism. So in simple words, I am telling you the cross-section is actually a side whose opposite side is exactly the same. Listen again. Cross-section is actually a side whose opposite side is exactly the same. So for example, this side is having opposite side exactly the same. This side is actually having opposite side exactly the same. But this side and this side is not same because these are like this, opposite slanting. But this triangle will exactly the same of the opposite. This top side will be exactly the same of the bottom, but right side will not be exactly same to the left, and front will not be exactly the same of the back. Likewise, top side in this is the cross section because top side will exactly the same as of the bottom. But okay, this front can also be the cross section because opposite side is exactly the same. So we can have some options in some questions. Likewise, in this question, right side is also can be the cross section area because the left side is exactly the same. Top can also be the cross section area. So in simple words, cross section is a side whose opposite side is exactly the same. A cylinder is a prism with a circle as cross section. So circle is the cross section of a cylinder. The table below gives the formula to find the volume for some common solids. So these are some common figures which frequently come in the paper whose volume is required. So concentrate yourself. Here is a cuboid whose length L, breadth B and height H is given. So volume for the cuboid is length into breadth into height, where L is the length, B is the breadth and H is the height. Now this concept will be cleared with the help of an example. We are given a cuboid whose length 9, breadth 3 and height 5 is given. Requirement is the volume. We will put all these values into the formula. So putting all these values into this formula will give us the volume of the cuboid. Here is another common figure, that is a cube. In cube, we are having all sides equal. So the volume of the cube is L cube, where L or S is the length of the side. So this concept will be cleared with the help of an example now. A cube is given whose side is 8 given and the requirement is the volume. So we will put this value into this formula. So volume is equal to 8 cube. Solve it on the calculator. You will get the answer. Here is another very important figure, that is a prism. and this dark shaded portion are called area of the cross section, and the length between two cross sectional areas is called the height. For example, if this is cross sectional area, opposite will also be the cross sectional area, so this length will be called the height. Likewise, if this shaded portion front area is cross section, so back will also be the cross section, so the length between these two sides will be the height. So the formula for the volume of the prism is area of cross section multiplied by height or length. So simple is height, you may call it height. Okay, now this concept will be cleared with the help of an example. In this prism we are given the values. So for example, this front area is a cross section because the back side is exactly the same like of this, so that's why we will call this side the cross section. So first we will find the area of the cross section. So these two sides 3 and 6 are parallel sides because this is a trapezium, students. So first we will find the area of the trapezium, that is actually the cross section of the prism. So the parallel sides are 3 and 6 and height is 4. So first 1 by 2 into sum of the parallel sides into height. So this formula is used. So put the values into the formula. This is actually the area of the cross section now, and this is the length or height of the prism because this is cross section and the back side is also cross section, so this pi will be the height. So now we will put area of the cross section 18 and height 5 into this formula. So 18 into 5, that is the volume of the prism. The next important figure is a cylinder. So for example, this is the radius of the circle and this is the height of the cylinder. So the volume for the cylinder formula is base area into height because base area is a circle and circle's area is pi r square and height is h. So formula is pi r square h, where r is the base radius and h is the height. Now this concept will be cleared with the help of an example. We are given a cylinder whose radius and height are given. Units should be in same. Pi's value is 22 by 7. We will put these values into the formula. Pi r square h. So pi's value is 22 by 7. R's value is 7. So 7 square. And h is 12. So put these values into the formula. Solve it on the calculator. You will get the answer. Here is another important question. The diagram shows a solid metal cylinder with central square hole of sides measuring 5 millimeter. So this is a hole of side 5 millimeter. The cross section of the circular solid has a radius 14 millimeter. So 14 millimeter is the radius of the circle. The solid is 20 millimeter long. This is the height of the cylinder. Find the volume of this solid. Okay, because the diagram is a solid metal cylinder and the volume is the requirement. So volume for the cylinder formula is pi r square h. Pi r square is the area of the circle, but in circle we are having a hole that is a square. So the first we will find the area of the circle. That will be equal to pi r square because r is 14. So pi r square minus, this is actually hole. So we will subtract the hole from the circle. So pi r square minus 5 square. That is now the area of the circle. So pi r square is now this one. So the formula for the cylinder is pi r square h. The volume's formula is pi r square h. So this is pi r square and h is 20. So put these values into the formula, solve it on the calculator, you will get the answer. Here is another question. The diagram shows a storage shed. Find the volume in cubic meters of the shed. So this shed is like a prism. So the front side will be the cross section because front and back will be exactly like the same, and none of the other sides will be same in opposite. So front side is the cross section. So first we will find the front side's area. And in front, we are having actually two trapeziums. One is A, B, C, D, and second is A, D, E, F. So look, area of trapezium ABCD and area of the trapezium ADEF will collectively make the front side. And the area of the trapezium formula is 1 by 2 into sum of the parallel sides into H. So for the left trapezium, 1 by 2, parallel sides are 190 and 220, and height is between them, that is 40. This is given. Likewise, plus on the right trapezium, 1 by 2 will remain as it is. Sum of the parallel sides are 220 and 170, and height is between them, that is 120. So solve it on the calculator. This is the area of the front side, that is a cross section. So now the volume is the requirement. So volume of the figure is area of the cross section multiplied by height. So this 200 is actually the length between two cross sections. So 31,600 into 200 will give us the answer. So 31,600 into 200 will give us the answer. Solve it on the calculator, you will get the answer. First, you will get the answer in centimeter cube. We see in the question, find the volume in cubic meter. So cubic meter is the requirement. So at this step, we will divide this value with 1 million. So we will convert the unit centimeter cube into meters cube. So this is the answer. Okay. The statement is calculate the volume and total surface area of each of the following, but we will find only volume because this is the topic for today, of each of the cubes. So the volume of the cube formula is L cube, and you will put the value of L, that is 24, in place of L, take the cube, and you will get the answer. Unit will be in centimeter cube. These parts are same. You will put these values into the L, and you will get the answer. Statement of the question is calculate the volume and total surface area of each of the following cuboids. But we will find only volume because this is the topic for today. Volume of the cuboid formula is length into width into height. So length is 15, width is 9, and height is 20. So put these values into the formula. You will get the answer. Unit will be centimeter cube. These two parts are same. Length, width, and heights are given. Just put these values into the formula and you will get the answer. Statement of the question is calculate the volume and total surface area of each of the following cylinders. We will find only volume today because this is the topic for today. This is a cylinder and the volume of the cylinder is formula pi r square h. Radius is 2.8. You will put 2.8 in place of in place of r. Take the square multiplied by h is actually 7. So put the values into the formula. Pi is 22 by 7. You will get the answer. Unit will be centimeter cube. This part is again same. This is diameter. Radius will be 6 and height is 35. Put the values into the formula. You will get the answer. The statement of the question is find the radius of each of the following cylinders. Volume is given, height is given. So volume is equal to pi r square h. Volume is 1584. Pi is 22 by 7. Radius is the requirement. And h is 21. So solve the equation, you will get the value of r. This part is same. So put the values into the formula, you will get the answer. Statement of the question is find the volume of each of the following prisms. So this will be the cross-sectional area. So volume of the prism is a cross-sectional area area of cross section multiplied by height. So area of cross section will be 22 into 25 because this is a rectangle, and the length between the two cross sectional areas is 38. So multiply this with 38, you will get the answer. Solve it on the calculator, you will get the answer. In this figure, this is the cross sectional area. So first you will find the area of the triangle. Base is 8, height is 9, so 1 by 2 into base into height. So this is the area of the cross section. Multiply it with 16, you will get the answer of the volume of the prism. Here are prisms. Requirement is same, that is the volume of the prism. So if we draw a line from here, this is total 25, this is 15, so this will be 10. So this is the cross sectional area because the opposite side is the same. First we will find the area of this full side. This is actually a rectangle plus trapezium, so 20 into 15 plus trapezium is 1 by 2 into height is 10 and sum of parallel sides, so 8 and 20 are parallel sides. So this is the area of the cross section. You will multiply this value with 26 because this is the length between the two cross sectional areas. So multiply by 26, solve it on the calculator, you will get the answer. Unit will be centimeter cube. Likewise, in this part, this is a rectangle and this is a quadrant. So 21 into 14, this is the area of the rectangle, plus this is a quadrant, so pi r square. This is 21, so 21 is the radius, so pi r square divided by 4. This is the area of the cross section. The back side will be exactly same, so this is the cross sectional area and the length between the two cross section is 24. So multiply this value with 24, solve it on the calculator, you will get the answer. Unit will be centimeter square.